Hello again, my name is Ryan Wallner and I'm a technical marketing engineer here at Pure Storage working on Portworx. And today we're going to talk about really what is a storage class and how do you know what storage class to use. So what we'll cover is sort of the basics of what a storage class is, what it means for Portworx to provide dynamic provisioning in Kubernetes, what options there are to work on and use dynamic provisioning with Kubernetes with Portworx. And there's a lot to cover there, and hopefully this video will give you a better sense of what parameters to use when, how to create a storage class with the right parameters for your application. And so let's just dive right in. So I have here the documentation website for Portworx at docs.portworx.com, and there's a install Kubernetes Storage 101 section which takes you through how to create a storage class. Here there's a few examples using some of the parameters. REPL will cover what that is. IO profile will cover what that is, what DB means. But this is a good resource, and I will put it in the description below or wherever you find this video. And there's some examples that you can download for MySQL, for instance, and the PVC spec as well as the storage class and the deployment. So this is a really useful resource to use. So let's hop on over to the dynamic provisioning page here on the Portworx website. And this is where you'll find every single piece of parameter that you can put in your storage class. So this is everything from what file system you want to use, XFS or etc4. This is really what the volume that you gets configured with this file system, and this file system is now available inside your container. By default, I believe etc4 is definitely used. REPL, we saw this before in the example. This is really a replication factor. So this really has to do with how available you want your data. And this will sort of change depending on the use case, which I think, we'll hop over on the Lightboard pretty soon to kind of give you a sense of what you would configure where and when for what use case. But let's keep going with this first. So shared is the equivalent of saying that you want an NFS volume. So shared is a way for you to create a storage class that produces volumes that can be shared across many different other applications. So say you're running a content delivery or a blog post or just a web front end that needs to access the same data, but it's a stateless service that only pulls from this volume. So it's actually not doing any writing at the same time as other processes. So it's safe to say that multiple servers of that same process can access the same volume. This is when you use a shared flag to say that multiple containers will access the same volume so they can grab the same data. Priority is really about the class of storage that you will find within your Portworx cluster. So say you have SSDs, NVMEs, and spinning disk. These can be labeled as high, medium, low, and a storage class can define this to say, there's a developer group that just needs low IO priority to do that. IO profile is really about what type of workload you're using. And so Portworx allows you to sort of tweak the way that it processes IO for a volume on a specific use case. So DB, sequential, random, sync shared is really about the type of application. So DB would be a perfect use case for databases, right? So this actually does a bit of right back flush coalescing in its algorithm, and some other things that are provided, such as how often it does syncs and when. So DB remote is actually the right name for this profile that we've updated, I think, as of 2.6. So DB remote in the IO profile, and so this would be perfect for your relational databases and MySQL, Postgres. Group is really about how you can provide a group label associated to multiple volumes. So say that you have a Cassandra database with multiple worker nodes. You'd want those volumes to be part of sort of a Cassandra group so that you can take sort of a consistent view or snapshot on these things. The FG flag is always set to true, and it actually forces the volume group policy. So, by default, this is sort of on. Labels is sort of an arbitrary list of labels for your Portworx volume. This is really useful if you're using the API or pulling information from the Kubernetes APIs or Portworx APIs directly, where you'd want to organize volumes from a test run or a CI pipeline or production, say, or even staging. Nodes is really used when you have a specific need for placing a volume on a specific Portworx node. Or Kubernetes node. This will allow you to kind of say, make sure this volume actually puts its data on these nodes. There's various ways to do this type of stuff. We have volume placement groups, volume placement strategies, which allow you to sort of do this by a rule and set where your replicas go and things like that. But nodes is another way to sort of strictly enforce it. Aggregation level is really about the number of replica sets across the node. So the behavior here is when you have a volume that's bigger than the storage available on a single node, you may want to aggregate the available storage and to be able to use on multiple nodes. So that's sort of the example there. The default is 1. Snap schedule. This is really useful if you want to sort of make sure any volume provisioned by a storage class is being snapshotted. So say in production, you as an administrator set up a storage class that all applications get, and you make sure you have a policy of a daily snapshot. This is a good way to do that. Snap intervals sort of related to the schedule. The sticky flag is really about, making sure volumes can't be deleted accidentally by an admin or something like that. Sticky is definitely one way to do that. A journal is a specific performance improvement for specific volumes. So you can have a journal for a single volume, a single application volume to get better performance out of sort of bursty workloads. Secure is really a way to encrypt your volumes. So secure, if you set it to true, it will expect a global key or a per volume key to encrypt the data within it. This is a great way to keep your data safe. And then there are another flag that has to do with Stork. We won't cover Stork today, but Stork is really a way to enable you to do more with your snapshots. Say you want to sort of offload to the cloud and things like that. We'll show you an example of what that looks like. But before we get into it, we do have a real environment that we'll start to work on. But before we do that, let's hop on over to the Lightboard and just kind of go through some of those examples. So I'll meet you over there. Okay, we're here at the Lightboard. So let's go through a few examples. I have production DB or database here. I have document delivery, say you're encoding or content delivery for documents or something like that. And then test and dev. We talked a little bit about, test and dev probably doesn't need as much. So let's start with our production database. I'd say we'd at least want a replication value of 2. You could argue 3 would be a good way to go, but at least a second replica so that it's in a different failure zone to the initial one. I want snapshots, so snapshots I probably want daily at least, maybe if not hourly, and then I'd also want cloud. So here I want to say that I want daily and cloud-based snapshots because, this is production. We want to be safe. We're going to set our priority IO to high, meaning that if we have SSDs or NVMEs on our host, we want to make sure our data lands on the high priority IO class of storage because it's a production database. We want this thing to be performant. I probably want to set up a journal. Keep in mind that if my priority IO is high and that lands on SSDs, then my journal should be some sort of NVMe device. Just keep that in mind. Your journal should be faster than your class of storage. So okay, we got replication, snapshots, priority IO, journal. I'm gonna say encryption. We're gonna set that to true. We don't want shared because it's a database. We want sort of the read write once way of doing things. And so I think this is a good way to go. I think that replication of 2 snapshots, both daily and cloud, high priority. Oh, we forgot one. IO profile. This is going to be DB for database, or DB_remote if you're running some of the newer software. This is a great production sort of database. For document delivery, let's go ahead and say the obvious one. Let's use a different color. The obvious one's going to be shared equals true. Because I see that my document delivery system is going to have a lot of front ends accessing the same sort of database of different documents. And so my shared equals true is going to make sure that this sort of acts as an NFS volume. And then we're going to make sure and set that access mode in the storage class to read write many. That's actually not done in the storage class. It's done in the PVC. Correction, do that in the PVC. When you create it, we'll go ahead and show sort of examples of both sort of the snapshot for cloud and daily or something like that. And then we'll also kind of show you how to, identify the access mode for the right storage class. So if you are using a storage class that has shared equals true, read write many is the way to go. I'm also going to say that my replication value is 3, right? So document delivery doesn't need to be super performant, but we want a lot of copies of it. We want it to be available. Documents are important. We want to make sure our data is available. So replication factor of 3. And it's documents. Who knows what's in these documents? So I'm going to say that we're going to set our encryption to true. So shared volume, replication factor of 3, and encryption turned on for my storage class for document delivery. So lastly, test and dev. I did these colors backwards. It's fine. Test and dev. I'm going to make this simple. Test and dev, we say we don't need snapshots. Let's say your data's gone by the end of the day, or your tests are short-lived. So let's just say a replication factor of 1, and that's it, right? So we want to make sure my data is persisted so that, if my container does stop and start, or I kill it or something like that, that my data still is persisted. But I really don't care about everything else. Test and dev. I'm going to test something. I'm going to blow everything away. So it just needs to be a volume and replicate. You could argue that you might need a certain level of class of storage. In that case, you'd set priority IO to like medium, but I would say low is fine. We could even go so far as saying that priority IO is low. So for test and dev, this isn't exactly the syntax you'd use in the storage class. We'll go ahead and jump back to our lab and take a look at what that looks like. But this just gives you a sense of, what storage class do I use for what application and when do I use it? And then, after you think through that, this is how you'd go about creating that. You make sure your replication values are right, your shared, your flags, your encryption flags, your priority flags, your profile flags, everything is kind of set. And there are ways for Portworx to, let Portworx create a bunch of storage classes for you in case you don't want to be part of this, in case you just want to get going and choose a storage class. Okay, well, let's go back to our lab. I'll see you over there. All right, we're back, which is great. And hopefully that was useful in terms of, getting a better understanding visually when you'd want to use the type of storage class and how you'd sort of think about going through adding what you need as an example. So here's our live environment. We're back in our live environment. We have a single master 3-worker Kubernetes node, and to get your storage classes, you can do kubectl get sc. And here I have set up a bunch of storage classes already. They are sort of pre-provisioned with a name that describes them loosely. So Portworx storage class REPL 3 shared. I can probably assume that, you know, this is a shared volume storage class and it has a replication of 3. So if you ever have sort of a way to say, hey, what's in this storage class, you can describe this. So for instance, PWX storage class is pretty generic. So we can actually go ahead and do a kubectl describe storage class and then give it the name. And here's everything that's in it. So we can see that this has a replication factor of 2 and really nothing else other than replication of 2. So if you want to REPL 2 volume, meaning that your data lives on more than one node, this would be a good storage class to use. The REPL 1 storage class is probably a great one, as we talked about in terms of test and dev, where you don't need snapshots, you don't need anything fancy in terms of performance. You just need a volume that writes data somewhere, and it's okay if things get lost, or we can recycle them in later stages. So that'd be a good way to do it. So how do you use one? This is a good way to kind of visually see this. We have a PVC definition here, right? This PVC definition is sort of a generic one where its name is app data and the app name label is app volume. So we're just kind of going to show how we would do a storage class. So here's where we would input our storage class. So let's drop back out, because I forgot what storage classes are here. What we're going to do here is we're going to choose that Portworx storage class, right? So here, let's open the PVC definition. There are sort of UIs that do this sort of thing as well. If you use OpenShift, it allows you to sort of place this information through a UI, which is, it's a little easier. I do know that our shared flag wasn't set with Portworx storage class. So in this case, read write once is perfect. Access modes is really about how the application can access this volume. So if I did have a shared equals true setting, I'd want to update this to read write many, which would allow many clients to access the data. And here I want to say, how much storage I want. So this is all thin provisioned with Portworx, and here I'm just going to say 10, right? So what we can do here is now kubectl create -f PVC YAML, and our persistent volume is created. So here we can do a kubectl get PVC. I might have some other PVCs here. I got Postgres running, but here's our app data, and it's bound, and that's our volume. So we've successfully created a PVC that referenced a Portworx storage class that has a replication factor of 2. And that's how you'd use a storage class. So let's get out of here and look at our storage classes again. I just want to see, we have a storage class example here with snapshots. So let's go take a look at what this looks like. Actually, we're just going to do describe again. kubectl describe storage class schedules. So here is a really interesting use case where it actually uses that stork definition. So here we can see that our replication factor is 2. We have 2 copies of our data when we use this storage class. Then we have a default schedule policy as daily. This is basically saying that our default snapshot schedule is going to use the policy name of daily. We didn't get into policies today, but this kind of just shows you sort of the flexibility of what you can do with a storage class. This probably takes a snapshot, every day. And that snapshot type is local, meaning that all the snapshots that you take are going to stay on this specific Portworx cluster, meaning that it will take up a little more space for that. Then we have a weekly schedule. So basically saying that, yes, we're taking daily local snapshots, but weekly we're going to say upload them to the cloud. So this is going to upload a weekly snapshot to Amazon S3, basically offloading for a little bit of extra data protection in case of a disaster, probably, that you could pull that snapshot back from object storage in the cloud. So again, this hopefully gives you a good sense of sort of the various different ways that you can use storage classes, how you go about thinking about what you should configure in your storage classes. If you're the kind of person that doesn't like to create your own storage classes, maybe you're an administrator that sort of wants a little more guidance, or a user that wants them created for you. Hopefully your DevOps team has someone creating them for you, or if you're managing these clusters, install Portworx with the operator flag. So if we go to central.portworx.com and you install Portworx, say Portworx Enterprise, use the operator. And the reason I say this is because the operator will go ahead and install a whole bunch of pre-created storage classes that you then can use this approach on to say, what storage classes do I have? Describe them to see what they provide. And then when you create PVCs for your applications, you can just choose one. And that's a nice part about using the operator. So again, take a look at the dynamic provisioning page for PVCs to get a refresher on all these parameters that you can use for your storage classes. And hopefully this helped you sort of understand how you can use those storage classes for your Kubernetes applications. And until next time, take care.